Out there in the cold reaches of space, beyond Earth's atmosphere, beyond the moon, beyond all that feels familiar, are machines that represent our best intentions. They don't look like astronauts. They don't breathe, eat, or sleep. But they go where no human has gone. They are explorers, scouts, and survivors. They are rovers. Every rover we've launched carries more than sensors and cameras. It carries our questions, our wonder, our refusal to stop at enough. They are machines, yes, but in them live the echoes of human ambition and the fingerprints of thousands of minds who dared to dream beyond gravity. These robotic pioneers move across foreign landscapes, not for conquest, but for connection. They dig and analyze not to dominate, but to understand. They are the beginning of our presence across the solar system, and their story is only just beginning. Mars was the first real test, a place close enough to reach, but alien enough to challenge every assumption. We began humbly, with orbiters and static landers, but soon realized we needed more. We needed mobility. We needed persistence. We needed machines that could survive the cold, the dust, the unexpected. So we built them, one by one, each rover a prototype of what might come next. Sojourner proved we could move. Spirit and Opportunity showed us how far we could go. Their discoveries transformed what we knew about Mars. They found signs of past water, complex geology, and a history far richer than we once imagined. Then came Curiosity, a rolling laboratory with a nuclear heart. She climbed mountains and sniffed the air for ancient chemistry. And now, Perseverance roams Jezero Crater, collecting samples that may contain evidence of life and storing them for a future we're still inventing. Her companion, Ingenuity, made history with the first powered flight on another planet, a moment that forever expanded what we believe is possible. These missions taught us not only about Mars, but about building machines that last, that adapt, and that persevere. They've laid the foundation for everything to come. But Mars is just the beginning. Beyond its rust-colored terrain lies a colder, stranger world of possibilities. Some of the most promising places in the solar system aren't planets at all. They're moons. Europa, Enceladus, Titan, Ganymede. These icy satellites orbiting giant planets may hold hidden oceans, chemical energy, and the conditions for life. Unlike Mars, which may have once hosted life, these places might host it now. Imagine a rover descending through the icy crust of Europa, diving into a subsurface ocean where sunlight has never reached. Or a robot skimming the methane lakes of Titan, tasting the alien air and sampling shores that have never seen a sunrise. On Enceladus, geysers blast water vapor into space. What if a future drone flew through those plumes, analyzing them in real time for amino acids and organic molecules? These aren't dreams anymore. They're engineering goals. NASA's Dragonfly mission will send a rotorcraft to Titan, flying from site to site across an entire moon. Europa Clipper will map and analyze Europa's surface and prepare the way for landers to come. This is the next generation of planetary exploration, one that ventures not just to dry ground, but to alien seas. The more distant the destination, the more alone a rover must be. Communication delays stretch minutes, sometimes hours. There's no joystick on Earth that can guide them in real time. These rovers must think for themselves. Today's rovers already use artificial intelligence to navigate terrain and choose targets. But tomorrow's rovers will go even further. They'll learn from their surroundings, adapt to the unexpected, make decisions without waiting for Earth to weigh in. We're entering the age of autonomous exploration, where machines act as scientists, not just tools. Imagine a rover landing on an unknown terrain and instantly mapping safe paths, identifying unusual rock formations, and running diagnostics on its own performance. These machines won't just obey, they'll collaborate. And with machine learning, they'll get better with time. Smarter, more efficient. One rover's success will inform the programming of the next. In this way, they become more than isolated missions. They become a fleet, a living system of mechanical explorers learning, evolving, and pushing the boundary of where we can go. All this engineering, all this risk, all this ambition, it centers on a question that is both ancient and urgent. Are we alone? We don't expect to find cities or creatures, but we do hope to find patterns, chemical signatures, biological markers, whispers of microbial life. Something that proves life is not a miracle exclusive to Earth, but a natural outcome of the universe's chemistry. Finding life, past or present, will be a scientific revolution. But even not finding it tells us something profound. It sharpens our sense of uniqueness. It informs our understanding of biology and planetary systems. It helps us ask better questions. Our rovers are the first to truly chase that answer with the tools to find it. Every scoop of soil, every drilled core, every spectrometer reading. These are steps in a treasure hunt whose reward is not gold, but understanding. These rovers do more than explore. They pave the way. Human footprints will one day follow the wheel tracks of robotic explorers. Before we send astronauts to Mars, we must know the ground they will stand on. Rovers will identify safe landing zones, locate underground ice for drinking water, measure radiation, test technologies that will sustain human life on alien soil. Some future rovers may even build, with robotic arms, 3D printers, and autonomous construction software, they could erect habitats before we arrive. Imagine stepping off a lander to find your first shelter already waiting. These aren't just support roles, they are partnership roles. Human and machine working together to push back the veil of the unknown. Most rovers do not come home. When their missions end, they are left behind, mute witnesses beneath alien skies. Some freeze, some fall silent in storms. Some are buried by dust and time. And yet, we remember them. We remember Sojourner, the first. We remember Spirit, who kept going even when her will broke. Opportunity, who explored for nearly 15 years and whose last message, "My battery is low and it's getting dark," broke hearts around the world. We remember Curiosity, who climbs still. Perseverance, who explores still. And Ingenuity, who proved that flight is possible even on another world. They are not disposable. They are monuments, not of conquest, but of curiosity, not of strength, but of resolve. Someday, humans may walk past them, brush Martian dust from their solar panels, stand quietly beside them, and recognize what they represent. The first steps of an interplanetary species. The future of rovers is not fixed. It is expanding, shifting, becoming. They will not only go to new places, they will go in new ways. Under ice, through liquid, across distant worlds with no names yet. Some may leave the solar system altogether, bound for interstellar space, carrying messages not just of exploration, but of us. In every rover, we send a little of ourselves, our creativity, our hope, our need to know what lies beyond. As long as there are questions to ask and stars to chase, we will build machines that go where we cannot, and they will take our dreams with them. This is not the end of the rover story. It is only the beginning.